so we are going to solve quadratic functions, and we are going to look at a couple of ways that we can solve them to start with. So the first method we're going to look at is solving quadratics by completing the square. So basically what we need to do is, if we're looking at an equation that looks like this, we are going to isolate the constant. So we're going to move the 22 to the other side by subtraction. And then we need to make this x squared minus 10x into a perfect square. And the way that we're going to do that is take b divided by 2. It would be b over like 2a, but we've got the a as a 1, and you want that as well. So b divided by 2, and so our b is negative 10 divided by 2 is going to get us negative 10 over 2, and then we're going to square the whole thing. That will be equal to negative 5, because negative 10 divided by 2 is negative 5, and negative 5 squared is equal to 25. So we find that 25 will make this our perfect square, but what we do to one side of the equation, we actually have to do to the other side. So we're going to add 25 to both sides, and we'll end up with x squared minus 10x plus 25 is equal to negative 22 plus 25. Well, when we add that, we'll get 3. When we factor this, it becomes x minus 5 squared. What I want you to notice is that x minus 5, well, that negative 5 part comes straight from what you had right here. So when we do this, you don't necessarily have to factor it. It should be this part right here coming in, and you'll see this on the next part as well, or the next example. So now we'll use the square root property and square root both sides. So we introduce the plus or minus. So x minus 5 equals plus or minus the square root of 3. So x equals 5 plus or minus the square root of 3, because we add the 5 to both sides. This is something to refresh you on. This is not something you have to know for this particular course. So for example 2, using completing the square again, if we have our example, or equation that looks like x squared plus 5x plus 2, again we're going to move the 2 over. So we subtract 2 from both sides and get negative 2. And then we've got x squared plus 5x plus what will equal negative 2. So we're going to do the same thing we did before, and we end up with 5 divided by 2. So we've got 5 over 2 squared. When we square both sides, because this won't reduce, we get 25 over 4. We're going to add 25 over 4 to both sides. We'll have to make the negative 2 into a common fraction so we can combine them. So negative 2 is over 1, so we've got to get it to 4. So we make that negative 8 over 4 by multiplying the top and the bottom of the negative 2 over 1 by 4. So 4 times 1 will get you the 4. 4 times negative 2 will get you the negative 8. And then we've got to add that to 25 over 4, which will get us 17 over 4. Now remember on the last one I told you you don't have to factor this, because factoring this with a fraction would be crazy hard to do. But remember, it's going to look just like this. So this is a positive 5 halves. We end up with a positive 5 halves. So x plus 5 over 2 here. And then we take each part. So we've got 17 over 4. We've got a square root property again. So taking the square root of both sides, we end up with x plus 5 over 2 is equal to plus or minus the square root of 17 over 4, which you can pull out the denominator to make it just over 2 at the bottom with the square root of 17 on top. And now you've got to move that 5 halves over, and you can leave them as separate or you can combine them. This is more of what you would see as far as a quadratic formula answer. And this would work just like it does with the quadratic formula. So with the quadratic formula, you're going to see that same kind of answer. So you could solve both of these with the quadratic formula if you prefer that. All right, so let's go look at some other options that we might actually use more so. You can use the completing the square, but I don't require you to do that. So the first type is factoring. Now we're just reviewing here, so if you need to know how to factor, go watch the video for comp exams because I have some factoring in there. So if we are looking at 4x squared minus 2x equal to 0, then we are going to factor out a common factor of 2x. We get 2x minus 1 left over on that. And then you're going to set each part equal to 0. So 2x equals to 0, x equals 0. And then 2x minus 1, you would find out that x equals 1/2. If we're looking at something like this, we're going to have to factor. Remember, I tell you I use the AC method factoring. So our a times our c would get us -8, trying to get to 7. The factors will end up being -1 and 8. So -1 times 8 gets you -8. When you add them, you get +7. So you use that -1 and that 8 to rewrite 7x. So you end up with 2x squared minus x plus 8x minus 4. You factor by grouping by taking the 4 parts and group it into 2 sets. And then you factor out the common factor on that side will be an x. The common factor over here will be 4. And when you do this, you should get the exact same part. And when those match, then that becomes your common factor, and you end up with x plus 4. Set them each equal to 0 and solve. And the same thing would happen here. This is the difference is it doesn't have a 2 or another number. It just has 1 in front, but the same process happens. You can go, once you know this and you have a 1 out front, you can go straight to your parentheses, or if you want, you can work it out that way. Either way works, but it works the same way. And then solve each one. So the square root property I mentioned in the square root part of the completing the square. So if we have something like 3x squared minus 15 equal to 0, we'll add the 15 over. Take 3x squared equal to 15, divide them by 3. We end up with x squared equal to 5. When we take the square root, remember when you introduce the radical and it wasn't already there, you have to do the plus or minus because you don't know if it was the positive or the negative of those things that when they were squared became the answer. So you have to put in that plus or minus when you introduce the radical. And we'll actually work some of these problems as we do the lesson. All right, so then we have something that might look like this. The x minus 2 squared equals 6, which is what we did on completing the square. Taking the square root of both sides, we'll get the square root of 6 with that plus or minus. Adding the 2 over, it's 2 plus or minus the square root of 6. Then we have quadratic formula. Hopefully you know how to do the quadratic formula from working on the comp part. But I put up some different scenarios here of what you'll get. So with the x squared plus 8x plus 15 equal to 0, remember you've got to find your a, your b, and your c. And you'll end up with plugging in. It's the negative of b. Here's your formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. This is also covered in the comp exam review, so you can always go look at that. And that's just some competency skills, some basic algebra skills that you need. And so we plug in all the values. You're going to reduce it down. As you get down to it, you might end up with an answer that looks like this. If you end up with all whole numbers, you'll reduce it by the negative 8 plus 2 and the negative 8 minus 2. So if they're all numbers, you actually have to solve down for the 2 values. Now another type of answer you might end up with is as you plug it in, if you end up with just a radical, then it might look like this. So you might get an answer with 2 numbers, an answer with a radical, and you might end up with an answer that comes down to imaginaries. So the imaginaries are going to happen when you end up with a negative value under the radical, and you'll have to remember that I is equal to the square root of negative 1. So you'll pull out the I and then reduce it down. In this case, the square root of 4 becomes 2, and you'll have to, because they all divide by 2, you'll actually have to pull out your, factor out the 2 and reduce it down. So those are just different ways. We're going to use these throughout the lesson, so I'll actually show you where I write them out, but I wanted to give you a review on different ways to do that as we're starting into this. All right, so let's get into 3.1. So here we are looking at solving some quadratic functions as far as graphing goes. So the standard form looks like this. F of x equals a times x minus h squared plus k. Our vertex is going to be h comma k. And depending on whether your a is positive or negative will depend on whether it opens up or down. The other type will be the general form, where f of x is equal to ax squared plus bx plus c. And you'll use the form, or the formula of negative b over 2a. That's similar to your completing the square. You'll notice that. It's similar to it. And then the value, once you find this value, you'll plug it back into the actual function to find the y value. And there's some basic steps that we need to do. We're going to first figure out what happens with it. Does it open up or down? We'll find the vertex. We'll find the x and y-intercepts. We'll plot any other additional points that we need. We're going to find the axis of symmetry, the domain and range, and the max or min. And there's some examples of this is what it might look like with an opening up graph and one that opens down. All right, so let's get into our first example. So we're going to work example 1. So we are given the function f of x is equal to negative 2 times x minus 3 squared plus 8. And we are going to graph this using the steps that we just went over. Remember, our formula is f of x is equal to a times x minus h squared plus k. So the first step we're looking at is, what does a equal? In this case, remember your a is out front. A is equal to negative 2. We don't really care about the 2 part. What we care about is it positive or negative. In this case, it's negative. So when the x squared is negative, we know it opens downward. And so I'm just going to draw arrows to show that the graph, the parabola, is going to open up, down. You don't have to write out opens up, opens down. Arrows work because that helps us see it on the graph. All right, step 2, we need to find the vertex. So for the vertex, remember, we're looking at h comma k, and it's always going to be opposite of what you see. So you see a negative 3, but the h is actually just the 3 because the negative is part of the formula. So our h is equal to 3, and our k is equal to 8. So our vertex will be 3, 8. The next step will be finding the x-intercept. Remember, when you find the x-intercept, that's where you set y equal to 0. And f of x is the same thing as y. So 0 equals negative 2 times x minus 3 squared plus 8. So we're going to move the 8 to the other side. So negative 8 equals negative 2 times x minus 3 squared. We always move it by doing the opposite operation. Then we've got to get this by itself, so we're going to divide by negative 2. So negative 8 divided by negative 2 will be positive 4 equals, and this will cancel. So that will leave us with x minus 3 quantity squared. Now we'll use that square root property we just went over. So that means we have to bring in a plus or minus. The square root of 4 is equal to x minus 3, because the square rooting will take care of the square. So the square root of 4 will be 2, so we'll have plus or minus 2 is equal to x minus 3. Let's add the 3 to both sides, and we end up with 3 plus or minus 2 is equal to x. So we'll actually have to finish solving that because we have x is equal to 3 plus 2, and it's also equal to 3 minus 2. Well, 3 plus 2 will get us 5, and 3 minus 2 will get us 1. So that means we have an x-intercept of 5, 0, and we have an x-intercept of 1, 0. So we'll actually have 2 x-intercepts. All right, step 4. Step 4 is to find the y-intercept. So the y-intercept is where we set x equal to 0. So y is still the same thing as f of x, so y equals negative 2 times 0 minus 3 squared plus 8. Well, 0 minus 3 is still just 3, so that'll be negative 2 times negative 3 squared plus 8. Following our order of operations, we have to do the squaring first. So negative 3 squared, and you could put this in your calculator, but that'll get us negative 2. Negative 3 squared is 9 plus 8, which will get us negative 18 plus 8, which will actually equal negative 10. So that tells us our y-intercept will be 0, negative 10. So again, I'm okay once you set this up if you use the calculator to get to the negative 10, but you've got to show me your work on your exam. All right, the next step, we need to graph it. So let's go graph this. So we're going to use what we have. We know we need negative 10 for the y value, and we need 5 and 1 for our x value. So we don't really need a lot on this side of the origin. So let's graph this. Oh, and our vertex we know is up at positive 8. So we're going to have to draw a pretty good size graph, but we're going to make small hash marks on it. All right, so I know I need to go at least 8 up there, so I'm going to go 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be our y's. 1, 2, 3, 4, 5, 6, 7. We'll go ahead and go 9 on this side. And I know I've got to go at least 10 because of that y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so we know our vertex is at 3 and 8. So it's going to land about right there. Our x-intercepts will be at 1 and 2, 3, 4, and at 5. And our y-intercept is at negative 10. And we know that the graph opens downward. So now we're just playing like connect the dots. So just try to do your best at sketching it. If you notice I'm doing this by hand, you don't have to use a calculator because you're going to have to graph it by hand on the test anyway. I mean, you can use your calculator to verify, but you really need to be able to do this. All right, so our next part, part 6, is the axis of symmetry. So the axis of symmetry is where it's symmetrical. Where does it mirror at? Well, that's always going to come from that vertex, the x value in the vertex, and it's an equation. So it is x equal to 3. Remember, our vertex was 3, 8. So x equals to 3. The domain is going to be, because it continues on, it'll be negative infinity to infinity, and the range is going to go from the, coming down from the negative side going up, it's going to be negative infinity all the way up to 8. It actually includes the 8, so it'll be negative infinity to 8 with a bracket. Part 8 is, do we have a max or a min? Well, we have a high point, so it's going to be a max, and we know it's a max because it's going from increasing and decreasing. Remember, that's where it changes direction. So we'll have a max at x equal to 3. The value is 8. It might ask you that in the homework, specifically like that. On a test, all I need is the 3, 8, which you'll notice is your vertex. So that's example 1. Let's go look at example 2. So for example 2, we are looking at the function f of x equals x plus 3 squared plus 1. So this is still in the format of f of x equals a times x minus h squared plus k. Now remember I told you it's always going to look the opposite of, because now we see a positive 3, but it has to be in that format. I'm going to actually rewrite it as it would be in the format, x minus a negative 3 squared plus 1. So it has to have the same format look. So now you can see that is actually negative 3. So it's going to be opposite of what you see when you're looking for that h. So here we go again, graphing. Part 1, our a, we don't see a value there, but we know then that it is 1. And it is positive, which is what we care about, which means it's going to open up, and we know it's going to look like that. Part 2 will be the vertex. So h is equal to that negative 3, and k will be positive 1. So the vertex is going to be negative 3, 1. Step 3 will be the x-intercept. Remember, that's where y is equal to 0. So we'll have 0 is equal to x plus 3 squared plus 1. So we'll subtract our 1. So negative 1 is equal to x plus 3 squared. Introducing our radical again. So we end up with plus or minus the square root of negative 1 equal to x plus 3. Now if you remember, the square root of negative 1 is I. So this will actually be plus or minus I equal to x plus 3. We'll subtract 3 from both sides. We get negative 3 plus or minus I is equal to x. So what does that mean? Because I is an imaginary number, which means it really doesn't exist. And so with that, and we still use them in math to solve big equations and that, but this will tell us for this instant that there is no x-intercept. So as soon as you see that you have a negative here, double check your math, but at that point you're going to know you don't have an x-intercept. So that means it's going to either be, since it's opening up, it's going to be above the x-axis. If it opened downward, we'd know it'd be below it. All right, let's go look at part 4, the y-intercept. That's where x equals 0, so y is equal to 0 plus 3 squared plus 1. Well, that'll get us 3 squared plus 1, which will be 9 plus 1, which equals 10. So we know that it'll be 0, 10 will be our y-intercept. Step 5, we're going to graph it. So we don't have any x-intercepts. So when we draw our graph, we know that we need to go as high up as 10. And we know that our vertex is at the negative side of x, so we need to have space on that side. But we don't need a whole lot down here. We'll go ahead and put 1 hash mark. We don't need a whole lot on this side, but we've got to go to at least negative 3 and a little bit beyond. So we'll go 1, 2, 3, 4, 5. Let's go to 6. 2, 3. So x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for y. And we can put an extra one just for good measure. All right, so negative 3, 1. That's our vertex. So we'll go over negative 3 and at 1. Our y-intercept is at 0, but we don't have anything else to graph. But remember, a parabola is going to reflect. So we know there's going to be a point over here opposite from that, just like it was on the previous graph with our x-intercepts. Remember, if you look here, there's a reflection because that's the axis of symmetry, so it's going to reflect over it. So we could draw this one. And so there should be a point like kind of opposite there. But because we don't have an x-intercepts, we know it's going to kind of be over at that same range. This is 1, 2, 3 over from here. So 1, 2, 3 over from the center of our parabola or our vertex. And this way, we can kind of make a guesstimation right there. You could plot a different point if you want, but if you understand that symmetry, you know it's going to graph this way. And remember, these are just sketches. I'm not looking for perfection. So that's our graph. Now we need to find part 6, which is the axis of symmetry. So the axis of symmetry is going to be at the vertex again. So x is equal to -3 because our vertex was -3, 1. 7, we're looking for the domain and the range. Domain, again, our parabola is going on and on, so it's going to be -infinity to infinity. And the range will start from the bottom. It starts at 1 and goes all the way to infinity, so it will be bracket 1 to infinity. And then part 8 will be whether it's a max or min. Well, our graph is opening this way, so that tells us this is our min. It's decreasing and then increasing. So we will have a min at x equal to -3, and the value is 1. And again, it's our vertex. So that would be what I'm looking for on an exam. Sometimes the homework words it out that way. All right, so that's example 2. Let's go on to example 3. So example 3, we're going to look at a function that looks like this. F of x equals ax squared plus bx plus c. We're going to follow the same steps. The only difference is going to be we will use a different formula to find the vertex. All right, so this will be example 3. So we are looking at f of x is equal to -x squared minus 2x plus 1. And we're at f of x is equal to ax squared plus bx plus c. And our vertex will be -b over 2a with the function of -b over 2a. All right, step 1. What is the graph going to do? Is it going to open up or down? Well, that depends on what a is. Our a is, again, still out front. A is equal to -1. So that tells us it is negative, which means it's going to be opening downward. Part 2, we need to find the vertex. So for that, we need to know what a is, and we need to know what b is. We've already found a at -1. Our b will be -2. So our x value is equal to that -b over 2a, so it'll be negative. B is -2 over 2 times our a, which is -1. So that double negative times a negative, will get us a +2, and the denominator will get us 2 times -1, which is -2, which will become -1. So now we find the function at -1. So whatever your x value ends up being, find the function at that. So we'll plug it back into our original formula, negative times -1 squared minus 2 times -1 plus 1. So that'll be -1 squared is +1. -2 times -1 will be +2 plus 1. Well, this will end up being 2 plus 1 is 3. 3 minus 1, well, 3 minus 1 will get us 2. So our vertex is going to be -1, 2. So that's our vertex right there. So all you got to do is find what the x value is and then just plug it into your formula. And this is all addition, so it doesn't matter the order so much. I try to do it by visually what I can see. All right, so next step, we need to find our x-intercepts. So the x-intercept is where y is equal to 0. The x-intercepts are not quite as easy for these because before you just plug in the 0 and it's kind of solving it. This one you're going to have to solve a little bit harder because it's a parabola. So 0 is equal to -x squared minus 2x plus 1. Well, this is kind of hard to factor, so what I'm going to do with a negative out front, so I'm going to multiply both sides by a -1. Or you could look at moving everything to one side or to the other side. So you still get 0, is equal to x squared plus 2x minus 1. So I'm going to try the AC method. So a times b, trying to get me to c. Well, a times b, that's 1 times, a times c, yikes, a times c trying to get us to b. So that's 1 times negative 1, which will get us negative 1, trying to get to a 2. Well, the only factors of negative 1 are going to be 1 and 1, where one of them is negative. The 2 is positive, so I'll put that there, but when I add them, I get to 0, so I cannot factor this. I'm actually going to have to use the quadratic formula. If it factored, it'd be a little bit easier. All right, so to do the quadratic formula, remember that the formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So my a is equal to, and it doesn't matter which one you're going to use. You can use either of them. I actually like this one because it has more positives versus negatives, so I'm going to use this part here. So a is going to be equal to 1, b will be equal to 2, and c will be equal to negative 1. All right, so we've got a is equal to 1, b is equal to 2, c is equal to negative 1. Let's go plug them in our formula. So we've got the negative of b, so negative 2, plus or minus the square root of 2 squared minus 4 times a times c all over 2 times a. Now remember to keep that all over. Some people shorten up this line too quickly and it does not go well. So make sure you keep that extended out there. All right, so that gets us negative 2 plus or minus. And I always put that in parentheses so I remember the whole thing. This one will always become positive because you're squaring the whole number. So 2 squared is 4. Negative times a negative is going to make that positive. 4 times 1 is 4 times 1 is still 4. All over 2. So negative 2 plus or minus the square root of 8 when I add the 4's, all over 2. Now I have to break down that square root of 8. So I'm going to come over here and take the square root of 8, and we're going to break it down into a factor tree. So 2 times 4 and 2 times 2. So with that, I've got the square root of 2 times 2 times 2. It's a square root, so I'm looking for groups of 2 of the same number. If that comes out, we end up with 2 times the square root of 2. The equal sign should be right there. So that will be what we plug back in. So that'll get us negative 2 plus or minus 2 square roots of 2 all over 2. Well, this can simplify. You can't simplify inside the radical. It's stuck in there, but the 2's will all divide by 2. So I'm going to factor out a 2 and get negative 1 plus or minus the square root of 2 all over 2. So I divided a 2 out of each part on the top. These will cancel, and it will be negative 1 plus or minus the square root of 2. So what does that mean? Because we were looking for the x-intercepts. And what do we do with that? Well, we're going to have to put that in a calculator to get an answer. Remember, though, you're looking for 2 answers, negative 1 plus the square root of 2 and negative 1 minus the square root of 2. Well, square root of 2 actually equals 1.4. As we plug that into the calculator, you'll end up with 0.4 and negative 2.4. So that means you will have an x-intercept of 0.4, 0 and negative 2.4, 0, which is what we're looking for. So that's a lot of work if it doesn't factor. All right, next step is the y-intercepts. Y-intercepts are way easier because you just plug in x for 0 in this case. So for the y-intercept, where x equals 0, we're going back to our original function, so y is equal to negative 0 squared minus 2 times 0 plus 1. So for this, you actually have to go back to the original function. If you don't, you won't get the same answer because you've, on the previous one, we had it set it equal to 0. And in this case, the y is not equal to 0, so you can't do the same thing. So go back to the original. So that tells us it's equal to 1. So that means that our intercept will be 0, 1. All right, so now we can actually graph. So for the graph, we don't have really big intercepts, and our vertex was not very big. So we don't need big numbers on this one. So I'm going to graph it. Notice again, I am graphing all of these by hand. I'm going to go to 5 just to kind of give it some 4, 5. We don't have very big numbers, so. All right, so our vertex was at negative 1, positive 2. Our x-intercepts were 0.4 is almost a half, so I'm going to count that at about a half, and about negative 2.5, so 1, 2.5. And then our y-intercept is at 1. All right, so our graph is going to kind of come up like this and come down like this. Didn't quite catch everything perfectly, but it's okay. It's a sketch. If you mark the point and you're off just slightly when you draw the line, it's all right. All right, so axis of symmetry. So the axis of symmetry will be x equal to, you'll see that it's at that negative 1 again, where our vertex is. Our domain, still the same, negative infinity to infinity. The range is coming up from negative infinity, and it stops at 2. So it'll be from negative infinity to 2. And then, again, we have a max value because it's increasing and then decreasing. So we'll have a max at x equal to negative 1 with the value is 2. It's our vertex again, so negative 1, 2.